everyone, I am Ma'am Weng and welcome to our video lesson for today. Before we formally start our lesson for this day, let us first have a recall of what you have discussed in your previous video lessons. You have tackled about the following topics. First is all about patterns and sequence. The second is about arithmetic sequence. And the third one is about arithmetic mean. So for today's lesson, our topic is all about arithmetic series. So in discussing the topic about arithmetic series, we have the objectives. At the end of the lesson, you're able to first differentiate arithmetic sequence from arithmetic series. The second, evaluate the sum of the terms of a given arithmetic sequence using the formula. And the third one, solve problems involving arithmetic series. Now let us first differentiate a sequence from a series. I know that you have already discussed about sequence, and I know that you are thinking already about the difference between the two. So what is the difference between a sequence and a series? So in your previous lesson, a sequence is defined as a list of numbers or things. Say for example, you have 2, 4, 6, 8, 10. Another example, you have 20, 15, 10, and 5. Another example, you have 3, 9, 27, and 81. So how about a series? What is a series? So a series refers to the sum of the terms in a sequence. Say for example, you have 2 plus 4 plus 6 plus 8 plus 10. Another example, you have 20 plus 15 plus 10 plus 5 plus and so on. And then you have 3 plus 9 plus 27 plus 81. So ngayon, ito ang tanong. Ano ang nakikita ninyong pagkakaiba ng sequence at ng series? Tama ang inyong sagot. Tama ang inyong iniisip na sagot. Kung titingnan ninyo ang mga examples ng sequence at series, sa examples ng sequence, ang mga terms ay pinaghihiwalay ng comma. Samantalang sa examples ng series, ang mga terms ay pinaghihiwalay ng plus sign. Now that you have already know the difference between a sequence and a series, let us now differentiate arithmetic sequence from arithmetic series, which is our first objective for today's lesson. Let us differentiate the two. So in your previous lesson, you have defined arithmetic sequence as a sequence in which the consecutive terms have a common difference t. Example, you have 1, 3, 5, 7, and 9. In this example, the common difference is 2. Since 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. Another example, you have 17, 12, 7, 2, and so on. Here, the common difference d is equal to negative 5, since 12 minus 17 is negative 5. 7 minus 12 is negative 5. 2 minus 7 is also negative 5. So these are examples of arithmetic sequence. How about an arithmetic series? What is an arithmetic series? So since you have already we have already differentiate a sequence from a series, we can easily differentiate an arithmetic sequence from arithmetic series. So arithmetic series is the sum of the terms in an arithmetic sequence. Example, you have 1 plus 3 plus 5 plus 7 plus 9. Another example, you have 17 plus 12 plus 7 plus 2 plus and so on. If you will analyze the given examples, the terms here are examples of arithmetic sequence since there is a common difference. And as you can see, the terms are being separated by a plus sign. So if we are going to compare an arithmetic sequence from arithmetic series based from the examples given, if we have 2, 4, 6, 8, 10, 1, 3, 5, 7, 9, 17, 12, 7, 2, and so on, under arithmetic series, it becomes 2 plus 4 plus 6 plus 8 plus 10. We have 1 plus 3 plus 5 plus 7 plus 9 and so on. And then you have 17 plus 12 plus 7 plus 2 plus so on. So, ano yung pagkakaiba ng dalawa? So, sa arithmetic sequence, we use a comma, as I said a while ago. And then, in arithmetic series, we use plus sign to separate the terms. Meron akong gustong ibahagi sa inyo na kwento. Bakang iba sa inyo alam na ang kwentong ito. Noong unang panahon, merong isang bata na napakatalino, lalong-lalo na sa larangan ng sipnayan o matematika. Ang batang ito ay nagngangalang Carl. Binigyan siya ng kanyang guro sa elementarya ng isang tanong para maging busy siya. Pero laking gulat ng kanyang guro dahil nasagutan ni Carl ang tanong sa loob lamang ng ilang segundo. The question is, what is 1 plus 2 plus 3 plus up to 98 plus 99 plus 100? Or shall we say, what is the sum of the first 100 numbers? Imagine elementary student answered the question correctly in a few seconds. And he explained to his teacher his answer. And ito yung explanation ni Carl. If you are going to add the first number 1 and the last number 100, the sum is 101. If you will add 2 and 99, the answer is also 101. And also the two middle numbers 50 and 51, you get the sum, you will get also 101. And how many pairs of 101? So there are 50 pairs times 101 is equal to 5,050. So 5,050 is the sum of the first 100 numbers. At ang batang ito na si Carl, ang napaka-cute na si Carl, ay naging isang mathematician at siya ay si Carl Friedrich Gauss. At dahil sa kwento ni Carl, nagkaroon tayo ng formula in finding the sum of the arithmetic series. So to find the sum of an arithmetic series, we have this formula. S of n is equal to n over 2 times the quantity of 2a's of 1 plus the quantity of n minus 1 times t. Or we can have this another formula in finding the sum. S of n is equal to n over 2 times the quantity of a sub 1 plus a sub n, where n is the number of terms S of n is the sum, d is the common difference, a sub 1 is the first term, and a sub n is the nth term. Okay, so now that you already know the formula in finding the sum of the arithmetic series, let's have some examples. Let's solve. So first example, what is the sum of the first 6 terms of the arithmetic series 1 plus 3 plus 5 plus 7 plus 9 plus 11? So to solve this problem, let us first write the given. So we have the first given, n is equal to 6, since you are asked to find the sum of the first 6 terms. Then we have s of n is equal to s sub 6. A sub 1 is equal to 1. A sub 6 is equal to 11. And d is equal to 2, since 3 minus 1 is 2. 5 minus 3 is also equal to 2, the common difference. So these are the given in this first example. Now, what would be the formula that we can use? In the two formula that I introduced to you, which formula can be used to solve this problem? So this is the formula that we can use to solve this particular problem. We have s of n is equal to n over 2 times the quantity of a sub 1 plus a sub n. So substituting the given values in the formula, we have s sub 6 is equal to 6 divided by 2 times the quantity of a sub 1 plus a sub 6. Simplify and then substitute the first term and the sixth term. 6 divided by 2 is 3 times the quantity of 1 as the first term plus the last term or the sixth term is 11. Then simplify. 3 times 1 plus 11 is 12. Multiplying the 2, the answer is 36. So therefore, the sum of the first 6 terms is 36. Let's check. Since we are asked only to find the sum of the first 6 terms, we can just add the terms of the arithmetic series. 1 plus 3 is 4, plus 5 is 9, plus 7, 16, plus 9 is 25, plus 11 is 36. So therefore, we can say that the sum of the first 6 terms of the given arithmetic series is 36. Okay, so let's have another example. Find the sum of the first 10 terms of the arithmetic sequence if the first term is 2 and the 10th term is 47. Let us first write the given. So as you can see, you're asked to find the sum of the first 10 terms given that n is 10, s sub n is equal to s sub 10, a sub 1 is 2, and a sub 10 is 47. So we have the first term and we have the last term. we have the value for n. So how we are going to find for s sub 10? Which formula can be used to solve this problem? So you can solve it by your own by pausing the video, and then if you're done answering, you can play the video. So let's start solving. So to solve this problem, we have this formula again. S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. Substituting the values, we have s sub 10 is equal to 10 divided by 2 times the quantity of a sub 1 plus a sub 10. Then we have 10 divided by 2 is 5 times the quantity of the first term is 2 plus the last term or the 10th term is 47. Simplifying it further, we have 5 times 2 plus 47 is 49. Then multiply the 2, we have 245. Therefore, the sum of the first 10 terms of the given arithmetic series is 245. So did you get the correct answer? Okay. Let's proceed to the next example. Third example. What is the sum of the first 12 terms of the arithmetic series 5 plus 9 plus 13 plus and so on? So as you can see, this is an infinite series. We didn't know the next terms. And you are asked to find the sum of the first 12 terms. So in the previous examples, first and second examples, the last term is given. So here, we didn't know the last term. So let us first write the given. So the given are n is 12. So therefore, s sub n is equal to s sub 12. And a sub 1 is equal to 5. The first term of the arithmetic series is 5. Then we have d is equal to 4. The common difference is 4 since 9 minus 5 is positive 4. 13 minus 9 is also positive 4. So these are the given. The question is, which of the two formula can be used to solve this problem? The first or the second formula? So we can use either of the two formula. So if you are going to use the second formula, we will first find the 12th term a sub 12. So to find the 12th term, let us have a recall of the discussion that we had about arithmetic sequence. This is the formula in finding the n term for arithmetic sequence. We have a sub n is equal to a sub 1 plus the quantity of n minus 1 times t. Substituting the given values in this formula, we have a sub 12 is equal to a sub 1 first term is 5 plus the quantity of n is 12 minus 1 times d, which is equal to 4. Simplifying it further, we have 5 plus 12 minus 1 is 11 times 4. Then we have 5 plus 11 times 4 is 44. Then add, we will have 49. So therefore, the 12th term is 49. Or this is the last term. Now that we have already have the 12th term or the last term, we can now find s sub 12 or the sum of the first 12 terms of the given arithmetic series. So to find the sum, we can just use this formula. S of n is equal to n over 2 times the quantity of a sub 1 plus a sub n. Substituting the values, we have s of 12 is equal to 12 divided by 2 times the quantity of 5 plus 49. Simplifying it further, we have 12 divided by 2 is 6 times the quantity of 5 plus 49 is 54. Multiplying the 2, we will have 324. Therefore, the sum of the first 12 terms of the given arithmetic series is 324. So there is another solution in this problem. So we have the given values. We have n is 12, s of n is s of 12, which is the unknown, a sub 1 is 5, then d is equal to 4. So using the first formula, s of n is equal to n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. Substituting the values, we have s of 12 is equal to 12 divided by 2 times the quantity of 2 times 5 plus the quantity of 12 minus 1 times 4. Simplifying it further, we will have 12 divided by 2 is 6 times the quantity of 2 times 5 is 10 plus 12 minus 1 is 11 times 4. Then we will have 6 times the quantity of 10 plus 11 times 4 is 44. Then we have 6 times 10 plus 44 is 54. Multiplying 6 and 54, we will get 324. So you can use this formula and we can arrive with the same answer as the first solution. Make sure lang po na alam nyo kung paano mag-perform ng operations. So you have to apply the PEMDAS rule. So therefore, the sum of the first 12 terms of the given arithmetic series is 324. So we will get the same answer. Okay, another example. Find the sum of the first 7 terms of the arithmetic series where the common difference is negative 5 and the first term is 45. So we are asked to find the sum of the first 7 terms where the common difference is negative 5 and the first term is 45. So how we are going to find the sum of the first 7 terms in which the given are the common difference and the first term is 45. So let us first write the given. N is equal to 7. Since you're asked to find the sum of the first 7 terms, then we have S sub n is equal to S sub 7. This is the unknown. And then A sub 1 is 45. Here we have the first term is 45. And then we have D is equal to negative 5. The common difference is negative 5. So the question is, what is the formula that we can apply here? So you can pause the video and then try to answer the question by your own and then play again this video. So let's solve. So this is the formula that we can use. S sub n is equal to n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. Substituting the given values, we have S sub 7 is equal to 7 over 2 times the quantity of 2 times 45 plus the quantity 7 minus 1 times negative 5. So we will have 7 over 2 times 2 times 45 is 90 plus 6 times negative 5. Then we will have 7 over 2 times the quantity of 90 plus 6 times negative 5 is negative 30. Simplifying it further, we will have 7 over 2 times the quantity of 90 minus 30. Then S of 7 is equal to 7 over 2 times 60. Since 90 minus 30 is 60, we can just cancel. So we'll have 7 times 30. The answer is 210. Therefore, the sum of the first 7 terms of the given arithmetic series is 210. So did you get the same answer? Okay, good. Okay, this is another example. What is the 20th term of the arithmetic sequence 28, 20, 12, 4, and so on? Find the sum of the first 20 terms. So in this example, in this problem, you are asked to find the 20th term and then the sum of the first 20 terms. So to find the 20th term of the sequence, we'll first write the given n is 20, a sub 1 is 28, the first term, d is negative 8, since 20 minus 28 is negative 8, 12 minus 20 is negative 8, 4 minus 12 is also negative 8. This is the common difference. So these are the given. Now, using this formula in finding the nth term for an arithmetic sequence, a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Substituting the values, we will have a sub 20 is equal to a sub 1, which is 28, plus n minus 1, 20 minus 1 times d is negative 8. We'll have 28 plus 20 minus 1 is 19 times negative 8. Then simplifying further, we will have 28 plus 19 times negative 8 is negative 152. Since we have opposite signs, different signs, we'll just subtract 152 and 28, then copy the sign of the negative. So we'll have negative 124. Therefore, the 20th term of the sequence is negative 124. So the answer for the first question is negative 124. This is the 20th term of the given arithmetic sequence. Now, let us now find the sum of the first 20 terms. Okay. So to find the sum of the first 20 terms, we can use this simple formula. S sub n is equal to n over 2 times the quantity of a sub 1 plus a sub n. We have the given values. We have n is 20. S sub n is equal to S sub 20. Ito yung hinahanap natin. Then a sub n is equal to a sub 20, which is negative 124. Then a sub 1 is 28. So using this formula, substituting the values, we have S of 20 is equal to 20 over 2 times the quantity of 28 plus negative 124. So we have 20 divided by 2 is 10 times the quantity of 28 minus 124. So we have 10 times the quantity times negative 96. The answer is negative 960. Therefore, the sum of the first 20 terms of the arithmetic sequence is negative 960. So did you get the same answer? So this will answer the second question. What is the sum of the first 20 terms? And that is negative 960. Example number 6. The sum of the first 10 terms of an arithmetic sequence is 530. What is the first term if the last term is 80? And what is the common difference? So here in this particular problem, the given are S of n is equal to 530, n is 10, a sub n is 80. So we are asked to find the first term and the common difference. So the question is how you're going to find the first term and how you're going to find the common difference. Which formula can be used? So you can pause this video to solve this problem by your own, and then you can play this video to check whether answer is correct. Okay, let's solve. So using the formula S of n is equal to n over 2 times the quantity of a sub 1 plus a sub n, substituting the given values, we have S of n is equal to 530, the sum of the first 10 terms. So S of 10 is equal to n is 10 divided by 2 times the quantity of a sub 1, the first term, which is the unknown, plus the last term a sub n is equal to 80. Then we have 530 is equal to 10 divided by 2 is 5 times the quantity of a sub 1 plus 80. Just copy, we have 530 is equal to, by distributive property, we will have 5 times a sub 1 is 5a sub 1 plus 5 times 80 is 400. Simplifying it further, solving for a sub 1, we will get 530 minus 400 is equal to 5a sub 1. Then we will have 130 is equal to 5a sub 1. Divide both sides by 5, we will get 26. So a sub 1 is 26. Therefore, the first term a sub 1 is equal to 26. So 26 is the answer in the first question. What is the first term of the given arithmetic sequence? So now, how we are going to find the common difference? So to solve for the common difference D, using the given values, we have a sub n is 80, a sub 1 is 26, the value that we solved a while ago, then n is 10. Using the formula in finding the n term for the arithmetic sequence, we have a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. Substituting the values in the given formula, we have 80 is equal to a sub 1, 26, plus n is 10, minus 1 times d. So d is the common difference and this is the unknown. We have 80 is equal to 26 plus 10 minus 1 is 9 times d. Solving for d, we will have 80 minus 26 is equal to 9d, and that is 54 is equal to 9d. Divide both sides by 9, we will get D is equal to 6. Therefore, the common difference is 6. So the answer for the second question in problem number 6 is the common difference is 6. So did you get the same answer? Okay, good for you. So there are so many applications of arithmetic series, especially in our real life situations. So sometimes an arithmetic series rather, can be applied in the growth of plants, in the formation of the rice terraces, in the construction of buildings, and in finding the seating capacity in a movie house or in an auditorium. So there are so many applications. Okay, so let's solve this particular problem. Real-life application of arithmetic series. The problem is Lance Uge, Vicky, and Eddie are grade 10 students of Kamhai who belong to the same class. They decided to save money as part of their friendship goal for the school year. They saved 100 pesos in June, 150 pesos in July, 200 pesos in August, and so on. How much will they save at the end of 10 months? So let us first write the given in this problem. We have a sub 1 is 100, d is 50, since we have the sequence 100, 150, and 200, and n is 10, since we are asked to find the savings at the end of 10 months. So these are the given. So what do you think would be the formula that we can use to solve this problem? So to find the total savings S sub n, we can use this formula. S sub n is equal to n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times t. Substituting the values in the given formula, we have S sub 10 is equal to 10 divided by 2 times the quantity of 2 times a sub 1, which is 100, plus n is 10 minus 1 times d, which is 50. Then simplified further, you have 10 divided by 2 is 5 times the quantity of 2 times 100 is 200 plus 10 minus 1 is 9 times 50. We have 5 times the quantity of 200 plus 9 times 50 is 450. Simplifying further, we have 5 times 650. The answer is 3,250. So therefore, they can save 3,250 pesos at the end of 10 months. So that's one of the applications of arithmetic series. So another example, find the seating capacity of a movie house with 40 rows of seats if there are 25 seats in the first row, 28 seats in the second row, 31 in the third row, and so on. So to find the seating capacity, let us first write the given. We have a sub 1 is 25 since there are 25 seats in the first row. D is 3 since we have 25, 28, and 31. The common difference is 3. And then N is 40 since we have 40 rows of seats. So these are the given. So what do you think is the formula that we can apply here in finding the seating capacity of a movie house? So to find the seating capacity S sub n, find the sum of the number of seats, the total number of seats in a movie house. We have S sub n is equal to n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. So substituting the values in the formula, you have S sub 40 is equal to n is 40 divided by 2 times the quantity of 2 times the first term is 25 plus n is 40 minus 1 times d, which is 3. And then we have S sub 40 is equal to 40 divided by 2 is 20 times the quantity of 2 times 25 is 50 plus 40 minus 1 is 39 times 3. Simplifying it further, we have 20 times 50 plus 117. Then 50 plus 117 is 167 times 20 is 3,340. So therefore, the seating capacity of the movie house is about 3,340. So this is another real-life application of arithmetic series. Okay, so for STE students, please answer the following problems. The first, find the sum of the first 100 positive odd integers. Second, find the sum of the first 50 positive even integers. Then the third one, the first term of an arithmetic series is 14. The sum of all the 12 terms in the series is 564. Find the last term. So you can pause the video to copy the problem, or you can just have a screenshot of this particular problem. The fourth problem, the first term and the last term of an arithmetic series are square root of 3 and 300 square root of 3 respectively. The sum of the terms of the series is 3,612 square root of 3. Find the number of terms in the series. Another problem, a man repays a loan of 65,000 by paying 400 in the first month and then increasing the payment by 300 every month. How long will it take for him to clear the loan? So you can just copy, or you can just have a screenshot of this problem, these two problems. So there are 5 problems that you have to solve for STE students only. So this is a special reminder to all of you. So you have to answer the activity sheets at the end of your module and try to make sure to answer the exercises in your module, especially the last part, the activity sheets. And then, thank you for listening. Have a nice day, everyone.